while you're getting ready, I will review this one that we've done already. You've already learned that you can draw the arrows and FOIL this out. I'm going to color code my arrows just temporarily because it's going to connect into what we're doing next. I color coded the arrows blue that came from the X and green that came from the FOIL. And this X multiplied by everything, it kind of distributed to everything in the second bracket. And the 4 distributed to everything in the second bracket. And that would be FOIL. We also learned that if we wanted to, we could have made a chart and had X and plus 4 and X and minus 2. And in that chart, filled in X times X is X squared, X times 4 is 4X, X times negative 2, negative 2X and negative 2 times negative 2, negative 8. And then these two are like terms, so when we write out our final answer, they could be combined, and you would get X squared plus 2X minus 8. The chart is very nice. However, students seem to like the arrows because it takes less space in their notes. It's just like, it's human nature. Things that are bigger, you're like, ooh, it's bigger. I want to use the thing that's smaller, which is okay. But what we're going to be doing today is looking at what happens if we have not a FOIL situation. We have a binomial here and a trinomial there. Okay? We can use the same ideas that we had from FOIL. We could use the chart. So what would the chart look like here? Well, this time, can you see that you would have an X squared, a 2X, and a 3, splitting this into 3, and on the other one, an X and a 3. So your chart would now have 6 boxes instead of 4 boxes. And it's not hard to multiply all the things. What is X times X squared? X cubed, and X times 2X. 2X squared, and X times 3X. 3X, and 3 times X squared. 3X squared, and 3 times 2X. 6X, and 3 times 3, 9. I'm going to circle those two in purple. Why? And those two in orange. Yes, they are. They're like terms. They're common. We could put them together. Can you see when I go to write my answer? I have an X cubed.
I think my note package is in my locker.
You want to go check it? And 3X squared plus 2X squared, that would be 5X squared. And the 3X and the 6X, that will be 9X. And then I still have the plus 9. So I combined the things that were alike. Yes.
Yeah.
Was it? Yes, thank you. Thank you. So this needs to be a negative. Oh, that's going to change. That's going to change this to negative and this to negative. And thank you for noticing that. That will change this number to 3.
And negative 9.
And this one to negative 9. Perfect. Good observation. So was adding an extra number harder for the chart? Not really. Was it longer? Yes. But we did exactly the same thing. We're also going to find out, I have it here. No, we're going to do, some people like to do this with this question. So I'm going to write out the question again. And this is like the FOIL method or the distribution method for this question. This is method 2. And I'm going to color code it just like I coded it on the FOIL one for review. This X is going to multiply here. It's going to have to multiply here. And it's going to have to multiply there. And this 3 would distribute to each of those. So we don't have an acronym for this one like FOIL because it doesn't work out nicely. There's like a whole bunch of different outsides, and I guess you could like FOIL or something, but it doesn't make sense to come up with a word.
So would you, it doesn't matter which one you do first.
It doesn't matter which one you do first. As long as this x multiplies by everything in that one. And then this 3 multiplies by everything in that one. Okay, so when I do that, now the problem with the, I'll call this the distribution method, is you have to remember where you were and not forget one. So your mind has to go, okay, x times x squared, that's x cubed. X times 2x, that's plus 2x squared. X times minus 3 minus 3x. And then I've done the blue ones, now I go plus 3x squared plus 6x minus 9. And then just like before, this one and this one are like terms. This one and this one are like terms. So I would get x cubed plus 5x squared plus 3x minus 9. Same answer that I got from the chart, but where when it gets bigger, the chart is nice because you don't forget, you have boxes to fill in. You don't forget where you are in your map. But as you get good at it, some people like the arrows method because they feel like it takes less space. Okay? Can you see where this would get complicated? Right? You'll eventually have x squared plus 2x plus 1, x squared minus 3x plus 5. How many arrows would you have? Yeah, there'd be like lots of arrows. Okay? Can you see the chart might be nicer here? You have 3 on the top, 3 on the bottom. There'd be 9 boxes to fill in. It wouldn't be too bad. If you did the arrows here, you'd have this one to everyone here. Switch colors. You'd have this one, everyone there. And then you would have this one to everyone there. And you have to multiply that all up.
I feel like the chart would be more organized.
It is. Once it gets bigger, definitely more organized.
Forget a number.
Then you won't forget a number. And the chart also really lines up. I want to just show you how a nice thing about the chart. If we did this one, okay, we would have x squared plus 2x plus 1, x squared minus 3x and plus 5. X squared, x to the 4. X squared 2x, 2x cubed, x squared 1, x squared. Negative 3, x cubed, negative 6x squared, negative 3x, and 5x squared, 10x, and 5. And you don't have to like, oh, where was I? Because it's super easy to get lost in the arrows. Like, which arrow was I on? Okay, so the chart is really nice. And another thing that's really nice in the chart when they get bigger is check this out with like terms. Look where your like terms line up on diagonals. So it's really easy to now go, my final answer will be x to the 4 plus 5x cubed. Ooh, isn't that pretty? X squareds, go away. There's 0 of them. You can write 0x squareds, but you don't have to write anything. And then you have plus 7x.
Wait, why would the x squared go?
Look at the orange ones. Add them up. 5 plus 1 makes 6. Minus 6 would be?
Oh.
Isn't that a negative 3x cubed? So it would be negative 1.
Oh, I missed the negative again. So that makes my purple one negative x cubed. And this is the frustrating thing about math, because you're doing a question and you check the answer before. And what would I have noticed when I checked the answer key? on this one that I got it wrong. And then you don't know, am I totally not getting this? Or did I make what sometimes students and I myself call, that was a stupid mistake, forgetting the negative, right? How many of you have made stupid mistakes on quizzes? Yeah? You get them back and you're like, oh, that makes me mad because I know that, right? Mistakes where you had no clue to begin with, you have no problem losing those marks, right? Yeah, you're like, yeah, I had no clue on this one. I'm not surprised I got 0 out of 2. But it's when you're like, I knew exactly what to do, and I made a stupid mistake. That's frustrating.
On the quiz, there was one that was not possible, right?
No.
No, they were all possible, right?
Yeah, they would have.
You say saying, no,
Dang.
come on.
We'll find out when we get to quiz.
Cause I might have guessed.
What would that do to you if I gave you a quiz where every question was not possible?
Nah, I
A factor,
factored
that would be terribly mean, wouldn't it?
You should do it.
10 questions, factoring, every single one not possible.
One of them I thought was not possible.
You'd go crazy. Okay, we're gonna have a factoring quiz tomorrow? No, just kidding.
I don't know about that.
10 questions. All right.
Just write not possible on the first. That's what I would do.
Now, you have multiplied more than 2 things before in your life. For example, if I ask you, what is 2 times 3 times 4? You could do that. 24. Good. 5 was close. I appreciate the attempt.
She's right though.
How did you do that? Right? Sometimes what makes harder math easier is if you pay attention to how you did the easy math. But sometimes the easy math is so easy that you don't pay attention to what you did. What you did when you did 2 times 3 times 4 is you probably did 2 times 3 and got 6. And then did 6 times 4.
Correct.
So you chose 2 of them to multiply first. And actually, one of the things I've been trying to show you in other examples is it doesn't matter which 2. Did anybody do 3 times 4 first? 12, and then times 2? Okay. And 2 times 4 first? You do 8, then times 3? It doesn't matter the order, but what you have to do first is choose 2 of them and multiply. The same thing happens when we get to multiplying here of this thing times this thing times this thing. You have to choose 2 of them to multiply first. And human nature is to pick the first 2. Right? When you have 3 things multiplied, if you do statistics, most people did the 2 times 3 first. It's just human nature, like, oh, those are the first ones, I'll do those first. So what we do is when we have more than 2, choose 2 of them, multiply together, write the answer, and now you'll have a new multiplication that'll be 2 things instead of 3 things. How would I multiply these 2? I would probably use my arrows here and distribute. So as a result, minus 4 times 3, minus 12x squared, and minus 4 times 2, minus 8x. I put that in brackets because that's the answer when I multiply those 2 together. And I still have the other one, 5x squared minus 2x plus 3. Oh, now I'm being super careful because now I think the chart would make sense, right? Because we've got one with 3. (5x squared minus 2x plus 3) negative 12x squared minus 8x and now I'm being really careful because I've already made so many mistakes with negatives. This one's going to be negative 60 and an x to the 4. This one's going to be positive 24 and x cubed. It's going to be negative 36 and x squared. The other nice thing about the chart method is you can get like, oh, someone sent me a text and you're distracted and you're like, oh, where was I? Oh, I'm right here. Minus 40 x cubed plus 16x squared and minus 24x. Check your diagonals. Sure enough, those are like terms. Those are like terms. So our final answer will be negative, negative 60x to the 4 minus 16x cubed minus 20x squared minus 24x. I'll just leave it for a second. Okay. Now I'm going to get you to add some words here. I'm going to get you to add above this there's kind of two major types of questions that you get in this unit. Some questions are expand and simplify questions. Expand means get rid of all the brackets, multiply everything out, and simplify means if you have any like terms, put them together. But it's important to know what expand and simplify is asking. Okay? The other type of question is working the other way. That's when the question says factor. Okay? And I have a story to tell of I don't even know how long ago this was, but I had a quiz, grade 10 quiz, and the question looked like this. Expand and simplify. And I could tell that the person had never paid attention to these words. Because this is what happened to them. The question started like x plus 3, x minus. So they're like, oh, okay, I know that I can FOIL. Okay, and they FOILed and they wrote out all their terms. Yeah, I'm going to show exactly what they did. They did it like x squared minus 4x plus 3x and then minus 12 and they're like, ooh, light terms. And then they were like x squared minus x minus 12 and they're like, oh, I bet you I can factor this. And then they went, okay, let's see, two things that are x, and x, 12, 6 and 2, 4, and they thought about it for a long time. They eventually like, yeah, it's going to be minus 4 and 3. They're like, oh, I can do the arrow, and they did this. They didn't realize. You see, they got right back to the beginning. And then they FOILed it again. And they kept going in circles until they made a mistake and they got one that could not be factored. And then they said, can't be factored, and they ended their question. And I was like, it's really important that you know what the words mean, right? And don't just look at the question and say, oh, what could I do next? Because you can definitely, can you see you could go in circles forever? Oh, I can expand this. And then be like, oh, I can factor this. Oh, I can expand this. Oh. And then just circles and circles and circles until eventually you make a mistake and have to stop. So, expand and simplify. That's what our answer looks like. Factor is when it would start like this and we would have to break it up into its factors. So the English words that we learn in a math class are important because they're telling you what you need to do and when to stop. Okay. What does this little 3 mean?
It does it 3 times.
3 times. So 2x plus 3, 2x plus 3, 2x plus 3. How do you multiply three things? You do two first. Most people would probably choose the first two. Anybody want to do the left or the up? Oh, it doesn't matter. They're all the same. So, we'll choose the first two. Would you FOIL this one or would you use the chart? Probably FOIL. So now, we're going to get a new answer here. 2x times 2x, 4x squared. Maybe you see that the outside and the inside are going to be like terms. Outside is 6x, inside is 6x. Putting them together gives you 12x. And then 3 times 3 is 9. So we chose the first two, multiplied them together first. You want to use the arrows or you want to use a chart? Chart, okay. 4x squared, 12x and 9, and 2x and 3. Good thing everything is positive. 8x cubed. Check your diagonals for like terms. Sure enough. It's 36. In grade 12, you get questions where that's like a 6 or a 7. You have 7 of them multiplied together. And you have to choose, well, you could choose 2 of them multiplied together, choose 2 multiplied together, choose 2 multiplied, and keep going that way. Can you see that that would take a very long time? So in grade 12, we learn a pattern that makes it faster.
If you have to do 6 times, you just do it twice and then you do 2 again.
Right, if I had, like right now, if I gave you this, 2x plus 3 to the 6,
Then you would just do that.
can you see that this would equal, why did I pick 6? Oh. That's what it would equal, right? And could you see that I could put those two together, and those two together as a first thing, leaving me with the 4x squared plus 12x plus 9, 4x squared plus 12x plus 9, 4x squared plus 12x plus 9. But then you would still have 3 things, and you have to choose 2 of them again. And probably use the chart method to find out what the blue times the green was. And then once you get that answer, you would use the chart method again to times it by the red. And this answer, when you are finished in the end, will have 7 different terms. Is it hard? Not hard. Time consuming? Yes. Okay? So we have to be careful in math. Sometimes there are things that are time consuming, and sometimes there are things that are hard. But we often associate time consuming with hard when it's not actually any harder than it was before. It's just longer, right? Like 2 times 3 is easy. 2 times 32 is just as easier but longer. 2 times 8,753,485 is a lot longer, but not necessarily harder. Okay? Give you a new formula. The area of a trapezoid formula. In fact, there are some people that say you should learn the area of rectangles, triangles, and squares all as trapezoids. So the idea of the area of a trapezoid is that you have two bases that are parallel, and the area is you add up those two bases, divide by 2 to find the average of them, and multiply by the height. When we look at what happens with regular numbers, let's say I gave you this trapezoid. The area of this trapezoid is 32. Can you see that the average of the top and the bottom is 8? And 8 times 4 would give me 32. Why is it that, let's draw this in. I'm going to draw this triangle in. If this is 6, and this was perfectly symmetrical, and they don't have to be perfectly symmetrical, but let's pretend it is, just for making things interesting and easy to figure out. If you have this, does it make sense that you could take this triangle, take it, cut it out, flip it around, there we go, slide it into there, and if I took this part away and slid it into it, now I have a perfect rectangle. That perfect rectangle still has a height of 4, but now has a length of 8, because the 2 that was up here is now down here, filling in this spot. So the reason we take the average when we're doing a question like this is because this part would get translated over here, and you need to find the average of the top and the bottom and make it into a perfect rectangle. Now, with numbers, you could think about it. With algebra, all of a sudden your brain gets clogged because the algebra makes it hard to imagine. But that's where we have the power of, oh, well, we've developed the formula. Could I figure this out with the formula? If I add my base 1 and my base 2, can you see that there's like terms? The top and the bottom, you would get 8x minus 4 and plus 2 would be minus 2. That's what I would get if I added them together. All divided by 2 times by my height, and my height is x plus 2. How do you divide a binomial by a monomial? Like if this is divided by 2, can you simplify this? Right? It's going to be a 4x minus 1. You have to divide everything by the 2. Kind of like distribution. So if you're dividing it by 2, you're going to get 4x minus 1. And that's going to get multiplied by x plus 2. We can still FOIL this completely, so now I can, here I'd probably draw my arrows. It's just a binomial times a binomial. 4x squared. Outside is 8x, inside is minus 1x, plus 7x, and then minus 2. I'm going to stop this video here.